So, what's the first thing that pops into your head when you hear Saudi Arabia? I bet it's oil, right? Maybe immense wealth. But behind all that, there's a startling reality. The kingdom is actually building a massive artificial river right through the heart of the desert. Yeah, you heard me. It's one of the most ambitious engineering projects in human history, and it's all driven by a single, desperate need.
This question, it just perfectly captures the wild paradox of Saudi Arabia. We're talking about a nation with unbelievable riches, but at the same time, it's one of the most water-poor countries on the entire planet. It really is like having a palace made of solid gold, but you only have 2 sips of water to drink. And that fundamental problem is what's pushing them to do something monumental, to literally reshape their own geography.
And this is the number that defines the whole problem. 0. That's exactly how many natural, permanent rivers flow through the entire country. Not one. It's the largest country in the world without a single river. Which, wow, that really puts the scale of their water crisis into perspective, doesn't it? So to really get why they're building this colossal river, we first have to wrap our heads around just how severe their situation is. Being a kingdom without rivers, well, it comes with some pretty unique and daunting challenges. I mean, just look at these extremes. It's wild. On one hand, you've got the global identity, oil and incredible wealth. But the reality on the ground, 98% of the country is scorching hot desert. The capital, Riyadh, gets just 116 millimeters of rain a year. Now, add a population that has absolutely exploded, from 3 million people in 1950 to over 26 million today, and you've got an unbearable strain on a water supply that basically doesn't exist. For decades, Saudi Arabia relied on what seemed like a miracle solution, a kind of hidden treasure of water, buried deep beneath the sand. But, as it turns out, this solution came with a ticking clock. And that hidden treasure was something called fossil water. Just try to picture this: a vast underground lake, water that's been trapped down there for millennia. For a long, long time, this ancient water met about 70% of the country's needs. But here's the crucial part. It is a non-renewable resource. Once you use it, it is gone for good. So where did it all go? And how did it vanish so fast? Well, back in the 1970s, the government had this big idea to achieve food security. So they launched a massive project to grow wheat in the desert. A noble idea, sure, but it was absolutely disastrous for their water supply. By 2003, farming was gulping down a staggering 85% of the nation's water. And the final nail on the coffin came in a 2016 NASA report. The reserves were disappearing at a rate of 2 trillion liters per year. And this chart just says it all, doesn't it? That giant slice of the pie, 85%, went to growing crops in the desert. It was a completely unsustainable policy that drained the country's only natural water savings account. It got so bad, the government eventually had to shut the whole wheat program down. Someone put it perfectly with this analogy. They were drawing all their power from a battery that could never ever be plugged in again. So with their main water source pretty much gone, they had to pivot. They had to find a solution that was radical, incredibly expensive, and almost unthinkable in its ambition. Okay, so facing a potential catastrophe, Saudi Arabia turned to engineering on a scale the world had literally never seen before. Their decision was kind of simple when you think about it. If nature won't give us a river, fine, we'll build one ourselves. And the scale is just, it's mind-boggling. Get a load of this number. The total planned length of this underground river network is 12,000 kilometers. No, that is not a typo. It's a network so massive it already holds a Guinness World Record. So how does this whole thing work? Well, the entire river is being built underground. This is key because it stops the scorching desert sun from just evaporating all the water. And we're not talking about small pipes here. These are channels 11 meters wide and 4 meters deep. The goal? To produce 9.4 times billion liters of fresh water every single day. And all of it comes from desalinating seawater. And just to put that into perspective, because it's kind of hard to wrap your head around, look at this. The Nile River, the longest natural river on Earth, is about 6,650 kilometers long. This artificial network they're building is nearly double that length. They are literally building an underground water grid that dwarfs the most famous river in the world. It's insane. All right, so the magic behind all this is desalination. They use 2 main tricks. The first one is called multi-stage flash distillation. It sounds super complex, but the idea is actually pretty simple. You boil seawater to create steam, and then you condense that steam back into pure water, leaving all the salt behind. They do this on a colossal scale, in chambers the size of football fields, and they even recycle the waste heat to generate more power. It's incredibly efficient. And then there's the second technique, reverse osmosis, which is even cooler, in my opinion. Here, they use immense pressure to force seawater through this special, super thin membrane. The pores in this thing are so microscopic that only pure water molecules can squeeze through. It blocks 99% of all the salt, minerals, even viruses. It's just an incredibly effective and energy-efficient way to make perfectly pure drinking water. But you knew there was a but, right? Creating billions of liters of fresh water every single day, it comes with a price. When you take all that salt out of the seawater, you have to put it somewhere, and that creates a massive environmental challenge. So remember this number, 9.4 billion. That's the staggering amount of fresh water this project can turn out every single day. An incredible achievement. But to get that fresh water, you're left with this: 329,000 tons of toxic, super-concentrated salt sludge, or brine. And that's the amount of waste they produce every single day. Just to make that number real for you, that daily salt waste is equal to the weight of 1,645 blue whales, the largest animal on Earth. It's an almost unimaginable amount of toxic byproduct. So what happens when you dump all that stuff back into the ocean? Well, it's not good. It raises the water's temperature and its salinity, creating these dead zones where beautiful coral reefs just die off and marine life can't survive. It puts the entire delicate coastal ecosystem of the Red Sea at risk. This is the hidden and very serious cost of making the desert bloom. Okay, so the challenge isn't just making the water, it's cleaning up the mess. And this is where Saudi Arabia is now focusing its innovation, on solving the very problem its solution created in the first place. And this is where it gets really interesting, because they're coming up with some clever ways to tackle this. One idea involves these deep-sea diffusers that spread the brine out over a much wider area, which dilutes its impact. But the more exciting idea is something called brine mining. They're figuring out ways to actually extract valuable minerals, like magnesium and potassium, directly from the waste. The ultimate goal? To turn this toxic liability into a profitable resource. You know, when you step back and look at it, this underground river is so much more than just pipes in the ground. It's a declaration of national ambition. It's a bold statement that human ingenuity and technology can overcome even the most fundamental geographic limitations. And in a wonderfully ironic twist, in 2027, the nation with 0 natural rivers is going to host the World Water Forum, basically showcasing their solution to the entire planet. And all of this leaves us with one huge lingering question. Saudi Arabia is betting its entire future that the answer is yes. But as they build their incredible oasis, the whole world is watching to see if technology can truly conquer geography and what the ultimate price of that victory might be.